Also uploaded as a podcast.
Yeah.
Okay, I'm recording, Patrick.
Okay. So trigonometry is the study of angles. So the first question really is, what is an angle?
It's the inside part of, well, two intersecting lines or a triangle, right?
Yeah, like when two lines intersect, they form an angle.
Okay.
But how can we measure it?
Actually, when two lines intersect, they should form four angles.
Yeah.
But we're looking.
But yeah, they do.
Okay.
But once you know one angle, you can figure out all the others.
Okay.
So the question of trigonometry is, how do we measure an angle?
Okay.
So before we talk about measurement, we have to kind of know what we're measuring.
Okay.
So the idea is that I'm going to use radians in this lecture, and I'll explain why in a sec. Okay, so draw a unit. So we can regard an angle as kind of like a circle.
Okay.
A circle's perimeter, because, when two lines intersect, we can just kind of rotate the lines until one line is, we can draw a circle.
Okay, I think I understand. So we have two lines intersecting. Let's just imagine they're eternal lines.
Mm-hmm.
The center point is the center point of our circle, right?
Right, yeah. Where the two lines intersect, that's where we put the center of that circle.
And then, whatever one of the angles we're looking for, we take any point in one of the lines, and we draw a circle, well, around with it being the radius of our circle, right?
Yeah. We draw a circle of radius 1 around the point where the two lines intersect.
Radius 1?
Yeah.
What's 1?
Unit.
Okay.
Sorry, no. Hang on. Yeah. And I'll explain why we use unit in just a sec.
By unit, you mean if we're measuring in centimeters, we take 1 centimeter?
Yeah, 1 centimeter if we're measuring in meters. Okay. So, I mean, theoretically we measure angles in their own units called radians, but let's just draw let's just imagine we're drawing a circle of unit radius.
Okay,
so the angle, where the two lines, these two lines will kind of carve out a portion of the circle, won't they?
Yeah.
Because the angle kind of forms a cone-like thing.
Right.
When it cuts out the circle. Okay, so
kind of a slice of pizza.
Right. Yeah, exactly. So we take this pizza slice, and we look at the crust, or the perimeter of the circle.
Okay.
And, we basically stretch it out.
Oh, we stretch it out. Okay.
Yeah, so because the perimeter is curvy.
Okay.
But we imagine that, if we pulled the line straight.
I think I understand. So as if we took the crust of the pizza, and then we let's say we put a string that was we put a string to measure the line of the pizza, and then we stretched it out.
Yeah.
Okay.
Yeah. And the length of that string
is radians?
The length of that string measured in our unit of choice will be the number of radians of the angle. So for example, suppose we have two lines that kind of are perpendicular.
Well, explain what perpendicular is.
I mean that they meet at right angles.
Okay. 90 degrees, okay.
Yeah. So we take two lines that meet at 90 degrees. And then we draw a circle around where these two lines intersect. The size of the crest, if you like, will be pi on 2 centimeters.
Pi on 2 centimeters. Can you type that out on Skype, please?
Yeah, sure. Pi divided by 2 centimeters.
Where are we getting the 2 centimeters from?
It doesn't have to be centimeters.
Oh,
whatever.
Two units. Okay, so if the unit is, to make it more realistic, let's say we take our units in 1 meter, so 1 meter. So then we would have 2 meters of rope if we stretch it out. Is that what you said?
We would have pi divided by 2 meters of rope.
Okay.
Which is, I think it's a little bit over 1 meter.
Okay.
Yeah, 1 and a bit.
And that would be the radians, angle of the angle.
Well, yes and no. We go from meters to radians when we kind of, the other point to realize is that our circle could be of any size. But the size of our circle doesn't matter. The size of the circle we draw doesn't change the angle.
So kind of what we do is
that once we know the size of our once we know the size of our circle. Once we know the radius of our circle. We divide the length by the radius. And we call that and the result is the measure of the angle in radians.
Let me just put that together. Pi is 3.4, let's say 3.15, okay? Divided by, we said our circle would be 1 meter, so it would be 2 meters, right?
Yeah.
2 meters.
Yeah.
Well, 3.15 divided by 2.
Well, 3.15 divided by 2. That's right, 3.15 meters divided by 2.
3.15 meters divided by 2 meters. Okay.
Yeah.
Okay, so that's the first thing we do. And then what do we do? What's that? What would you call that?
Oh, no, sorry. It's 3.15 meters divided by 2.
Not meters. Okay.
Not meters, no.
Okay.
And we call that the, let's call that the linear, we'll call that the linear measurement of the angle. Or like the, I don't know what to call it. Call that the arc length. The arc length.
Of the angle?
Yeah.
Okay.
And to go from the arc length
to...
it's the arc length.
So yeah, it's the arc length of the circle.
Because the arc length depends on two things.
The arc length depends on two things. It depends on the size of our circle.
And it depends on the angle.
And it depends on the
to
angle.
Go from the arc length of to radians, what do we do?
We divide by the size of the radius.
We divide by the size of the
radius.
radius.
We would divide by 1 meter.
So we would divide by 1 meter.
Which is 1 meter. Okay.
Yeah.
And then that would be radians.
Right.
Okay. And then, sorry, go ahead.
Yeah, so now you kind of have an idea of what angles mean and what we're measuring.
Okay.
So all in principle, all trigonometric problems can be solved by this method.
Okay.
this method can get very complicated when we have weird angles, or when we don't want to draw a circle, or when we don't want to have pi in the mix.
Okay.
So on. So we use functions.
Kind of for the same reason that we use
log tables. It makes our calculations a
Can
lot
I ask
easier.
you, I think I already have this in my program, but I'd like to know how to convert radians to
Degrees?
Degrees, yeah.
Yeah, sure thing. You multiply by 180 divided by pi.
Okay. And then what?
That's it.
You multiply 180?
Yeah, to go from radians
to degrees, you multiply by 180
You multiply the
divided by
radians
pi.
by 180, and then you divide it by pi.
Yeah, and then you divide by pi.
And to go the other way around.
You multiply by pi, and then divide by 180.
So the degree method.
So the degree
I
method.
didn't write everything down. Let me go the other way around is what? Wait, this is
multiply
radians to
degrees.
Degrees. And then the other way around, degrees to radians would be what?
Multiplied by pi.
Multiplied by pi.
And divide by 180.
Divide by 180.
Yeah.
And this would be degrees to radian.
Yeah.
Okay.
So both degrees and radians are methods of kind of measuring how much of a circle we take up. And an angle can really be regarded as how much of a circle are we using.
Okay.
Yeah. Without the 90 degree angle uses up a quarter of a circle.
Right.
So the degree method is that we cut up the circle into 360 equal parts.
Okay.
And each part is called a degree.
Okay.
And they go further.
If you want even
finer measurements, they divide the degrees up into minutes and seconds.
So you're saying that it's 90 degrees because if we divide 360 by 4, that should be 90.
Yeah.
That's why our right angle is 90 degrees.
Is 90 degrees. Yeah.
So the mental image would be like to have a kind of a what do you call it? A kind of a clock with all, but instead of having the time on it, it would start off 0 pointing directly to the right.
Yeah.
And then
go
up.
Yeah, go anti-clockwise.
Yeah, go anti-clockwise.
Anti-clockwise?
The convention is usually we measure angles anti-clockwise.
Okay, so then the first tiny sliver of the 350 would be 1, and to the left, going from pointing all the way to the right, it would be one sliver of a 360 slice pizza.
Yeah.
Okay.
Yeah.
And then if we wanted to take a quarter of the whole pizza, that would be 90 slivers.
Yeah, exactly.
And that would be exactly a right angle. Okay.
Yeah.
I think we've developed a clear mental image of what we're talking about. Yeah.
Just to revise the points. An angle is some section of a circle. we can measure the angle in two ways. Contingently, we can measure it with degrees, where we kind of cut up the circle into 360 parts and see how many parts.
You know what else I forgot, Patrick? I forgot to use the mic that I have to use when I record on Skype. So your voice is going to sound like super echo-ish.
Idea.
Maybe.
We're not publishing this, are we?
Well, we're not publishing
maybe
this, are we?
we can re-record it another day.
Yeah, okay.
Yeah, basically we could even make like a YU kind of thing on these more things, because they should have gone over this, but they didn't.
I hope they're getting up to it. I think they want to cover the algebra first, and then they'll get up to trigonometry. At least I hope so.
By what I could see, the part of YU seemed to be skipping into like more just plain mathematical things.
I think they wanted to.
I think they wanted to like teach the logic of that. I had a very good picture to explain what sine and cosine mean.
You mean an internet picture?
Yeah.
Okay.
Yeah.
Here we go. It's the second one.
It's the second one.
One second. It's still loading. The second one. Okay. So that kind of an O thing is called a theta, right?
Yeah.
Okay, so sine is one of the sides of a triangle formed inside the slice of our angle, right?
Yeah. I like to think of it in terms of Cartesian coordinates.
Okay.
Like if we draw a circle on the grid.
Okay.
And then the x coordinate tells us that So we have an angle. And by convention. So you may think to yourself, there's only one line here to have an angle. So by convention, the other line always points to, is always just the x-axis. It is always just the horizontal line point. It's always just the horizontal line in the center of the circle.
Sorry, I'm not sure I follow. The x-axis, which? Are we talking about the red line here? That's the sine?
No. My point was that how can you have an angle when there's only one line in this diagram?
Okay.
And the way and the second line, we always take the second line to be the same. And that line is always the line that goes straight to the right.
Okay.
Okay. So once we've got the angle, we can make a line. So the point where this line hits the circle
is the sine.
No. Just call this, I don't know what to call this. Call this the, call it the coordinates of the angle.
Okay.
By which I mean the coordinates of where the first line hits the circle.
Okay. By the first line you mean the line marked by 1?
Yeah. Yeah. So the x coordinate of this point will be cosine. and the y-coordinate of this point will be psi.
Okay.
And this gives us a method of measuring cosine and sine directly. You know, we just build a grid. And we draw a circle in the grid. And,
Okay.
you know, the finer the grid is, the more accurately we can measure sine and cosine.
Okay. And then, when we draw a line from that point back, it seems apparently they're making a right angle from that point to draw the tangent.
Yeah. Yeah, that's right. So, a tangent to a circle is like you make a line, and you just want that line to touch one point on the circle.
Mm-hmm.
And that point is the point of our angle.
But why couldn't the tan be like in a different angle? Because it's 90 degrees it's 90 degrees from line 1?
If the tan was at a different angle, if the tangent line was at a different angle,
Mm-hmm.
then it would cut the circle. Like, it wouldn't just pass through that one point, it would kind of go into the circle,
Okay.
and then come out the other side.
Okay, so you're saying this is perfectly aligned with the circle's point. So, basically I should think of this tangent like with the line going through, like the line going past that point.
Yeah.
Not, okay.
Yeah, and it just skims the point.
Okay. So, is it always so it must be always 90 degrees.
Yeah, the tangent line is always, is always perfect. Yeah, it's always 90 degrees to the radius.
Why does it say on this, why does it say cosine theta and sine theta?
Because, the theta is our angle.
Okay.
And sine and cosine are always, and all this stuff is always defined relative to some angle. So before we can calculate sine or cosine, we need to know what angle we're working with.
Okay. Oh, right, because that's the cosine and the sine of the angle theta. Okay, I got it.
Yeah.
Which is the x and the y coordinates. That's all.
Yeah.
Okay. Well, that was pretty easy to understand.
Yeah.
Thanks, Patrick.
Alright. My pleasure. So it's kind of funny, the rest of trigonometry, like, I had to kind of come across this explanation. I don't think it was really explained to me properly the first time I learned trigonometry. I just learned a whole bunch of rules.
Mm-hmm.
But yeah, I like to think in terms of like, how do we measure stuff?
Mm-hmm.
I think it seems to me like a more down to earth way of looking at things.
Would you have any idea of what I was talking about, the A tan2 function? Would that look like a line in this?
The A tan2 function would be, give me a point, and I'll tell you I kind of have to define, I haven't really defined tangent, have I?
Okay.
How do I define tangent, sorry? You know how we can like talk about the equation of a line?
The equation of a line, no.
Yeah, that y equals mx plus c.
Y equals, what's mx and, no, I don't know what mx and c is.
Okay, so the idea is that when we draw a line,
Okay.
We can describe this line with a linear function.
I don't know what a linear function is.
I'm just about to tell you.
Okay.
The idea is that the y coordinate is just some multiple of the x coordinate that's shifted up or down.
Okay.
So for example, y equals x. That line is the line kind of going 45 degrees up from the x-axis.
Okay.
Anyway, the point is that any line can be put into this form.
Okay.
And we call that the equation of the line.
Okay.
So what tan does is it measures the value m.
Okay. So mx means m times x.
Yeah.
Okay. What does c mean?
So, C is a constant value. C is basically how much
how many units?
No, it's how much we shift the line up or down.
Okay.
We don't really need to worry about that for tan, but because if we didn't have that C there, then all lines would pass through the center of the circle.
Okay.
And we don't necessarily, and we don't want that.
Okay.
So to measure tan, we draw this tangent line. We find out the equation of the line, and tan of the angle is the value m.
Okay.
So for example,
in this case, the line would be like line 1 in...
Yeah.
Line 1 is 45 degrees, right? In what we're saying.
I think so. Let's just pretend it is.
Okay. So 45 degrees. So that would be x equals y.
Yeah.
Okay. And
y equals x.
Y equals x. Okay.
Mm-hmm. Oh god, I think I misled you slightly. Just to be clear, we're talking about the I think I was implying that the line that we want to get the line that we want to get the equation of is the line marked with 1.
Okay.
Yeah.
But in this case, it looks like 45 degrees, so we can say that y equals x, right?
Yeah.
And then what would the m be there?
The m would be 1.
Oh, a length of 1. Okay.
Not a length, a slope.
A slope of 1. Okay.
M controls how, tangent kind of measures how steep the line is.
So if let's say for example I changed m to 2, what would the line look like?
What would the line be?
Yeah. That's easy to calculate?
So if m was 2, then sine would be the sine coordinate would be twice the size of the. If m is 2, then tan is 2, and sine theta would be twice cos of theta.
And twice cos of theta. Okay.
Mm-hmm. Yeah.
There's another way.
There's another way of.
There's
kind of another way of defining tan.
Mm-hmm.
Which is the same thing.
Which is the same thing, but like.
It's an equivalent definition.
It's an equivalent definition, but it's another way of measuring it.
So
go back to the diagram.
We can also define
tan,
and this definition is probably better in some ways. We can also measure tan,
I should say, by drawing the tangent line to the circle.
Mm-hmm.
The blue line
in that diagram marked tan.
Mm-hmm.
And we measure how long that line is.
Okay. Yeah, that's why it looks blue in that.
Yeah.
And let me just be clear. Okay, so tangent means, well, in regular English, tangent means to go off course. To go out in a tangent, right?
Mm.
Now, in this case, it would seem that that tangent is to go 90 degrees.
Of course.
90 degrees to the right. Well, 90 degrees to the right of the point that of the angle theta.
Yeah.
And then draw a line until you hit draw a line until it hits the until the y coordinate is 0. Is that right?
I think so, yeah.
I think so, yeah.
Let me explain
why. Let me kind of connect the two definitions.
Okay. Imagine that you're
swinging around
a pole.
Okay.
And you're attached to
a rope.
I'm swinging around a pole and I'm attached to a rope. I'm attached to a rope?
Yeah.
Okay.
Yeah, so
you're going round and round a pole.
Okay.
And
the rope is making sure that you don't fly off.
Okay.
So if for some reason
the rope was cut,
then you would go flying off.
Okay.
And you'd go off course.
Okay.
And
you would go off course.
If we knew your angle at the moment, if we knew what your angle was, as soon as the rope was cut, then we would know that you would go off course in the direction of the tangent line on that angle.
Let me see if I can digest this. I'm swinging around with a rope. I'm swinging around with a pole in my hands.
No. Like the pole's on the ground.
On the ground.
And you're like holding a rope.
And you're like holding a rope, or
you're holding a rope. And
you're holding a rope, and you're kind of like flying.
Okay, so the rope is attached to like the top of the pole.
Yeah.
Okay.
Yeah.
I got it. Actually, hold on one second, Patrick. What's the name of this? Los Rada of Cholula. Yeah. Los Voladores de Cholula. I think there are people that do that.
There's also
a game where you're replaced. Have you had a swing ball?
Okay.
Or tetherball.
Well, can you just verify? Take a look at this video.
Okay.
Los Voladores de Cholula, and tell me if this is pretty much the situation you're thinking about, except one person instead of 4. Yeah, you can fast forward it because it's gonna take a while for them to start off.
Yeah, exactly.
Okay.
So, if I was one of these guys, and instead of being 4 guys, I was just 1.
Yeah.
And, the rope was cut. Then what would happen?
Then you would go off you would go on a straight line, so you wouldn't go around in a circle anymore.
Okay.
You would go in a straight line.
Okay.
And you would basically continue along the path, and you would go in the path of the tangent line.
Okay.
Yeah. Say for example, we knew your angle was, your angle, say we had some line on the ground where we could measure your angle from.
Okay.
And your angle on the rope was cut is 45 degrees.
Okay.
Sorry, call it 90 degrees just so I can visualize it more easily.
Okay.
Then you would just keep going. You would just keep flying straight to the left.
Okay. To the left.
Yeah, like
in the
not your left, but like the left from a global point of like.
Okay.
Yeah, like if we had a bird's eye view,
okay.
and you were like going around the pole.
But on the diagram you showed me, it seems to be, the tangent seems to be a line drawn to the right.
Yeah. You're right, but this, just imagine we extend this line the other way.
Okay.
Yeah. That's the direction you travel. Assuming you were going anti-clockwise.
Okay.
If you were going clockwise, then you'd travel to the right.
And the rope is line 1,
yeah.
right? Okay.
Okay, sorry, that was a little bit complicated, but
so, okay, so are we looking at, so we're extending, the tan line can be drawn through, so this diagram says tan there, but it can go through past the point that we're looking at. Okay.
So the segment of the tangent line from the point to the x-axis
is the tan.
Yeah, that's the tan.
Okay.
And the steeper, I'm going to call the one line the radius.
Okay.
Okay, so the steeper the radius is, the longer the tangent line, the longer that tan segment, the longer the blue segment will be.
Okay. Yeah, that makes sense.
And when it's infinitely steep, when the line is pointing straight up, then tan will be infinity. Or undefined.
Oh. So if we take the tan of 90 degrees, it will be infinite?
Yeah.
Okay.
Yeah, so we can't take the tan of 90 degrees, basically.
We can take the tan of any other degree?
Yeah.
So what would it mean if instead of this being 45 degrees, what would be the opposite of 45 degrees? Extending in the negative direction of the same line.
Actually, tan would be the same thing.
What? So tan would be the same thing?
Yeah. Because the equation of the line is still the same. Wait,
okay.
like, Yeah, if you turn the radius into a diameter, like, if you take the radius, and you just draw the whole line of the radius, like you extend it infinitely in both directions.
Okay.
Then, hang on. Yeah, then the point on the opposite side of the circle is covered by is on the same line.
So I think I'm just trying to ask, what if the angle is different? How do we calculate tan? If the angle is not 45 degrees.
Okay.
If it's something like, say, totally out that wouldn't form a beautiful triangle like we have right in this diagram.
Right. Well, in some sense we can always form a beautiful triangle, but
okay. Except in 90 degrees.
Except in 90 degrees, yeah.
Okay.
Or negative 90 degrees.
I think 90 degrees or any other straight angle seems to be impossible to make.
The straight angles can kind of give us a bit grief, but they're easy.
Okay.
There's only 4 of them, and we just think about the problem logic.
So 90, 180, 360, and 0.
Yeah.
We can't get the tangents of any of those.
Yeah.
Okay.
Although I think we just define tangent 0 in the 0 and 9, and the 0 and 180 case.
Okay.
Okay, so, yeah, I mean, this kind of makes sense because we're already on the x-axis.
Okay.
So the length of our tangent, so the length of the segment of the tangent line. I mean, the tangent line would be a vertical line.
Okay.
Going straight up and down.
Okay.
But, you know, the point's already on the x-axis.
Okay. But what I'm trying to ask is, what happens, for example, if the angle were 270 degrees?
It would be undefined.
It would be undefined? Tan would be undefined?
Yeah. There's a little app you can play with.
Is that the Euclidean one you told me about?
Yeah. No. Like, on the website.
Okay.
Just below the second picture, there's a...
Okay. Oh, yeah. Let's see. Doesn't say how many degrees, though. Does it say how? Oh, yeah, it says the degrees on top. But does it say what the degrees of theta is? I think we're supposed. Okay, so why are you saying that 270 would be undefined, Patrick?
Well, 270 degrees is when the radius is pointing straight down.
Is it? Okay, that's not what I meant then.
Okay.
What I was trying to mean is, if it was a little bit more, let's say half between straight down and half between to the right. I'm not.
So I would call it like, I don't know, 130 degrees, say.
Let's say 270 degrees plus 45 degrees.
Okay.
Yeah.
Then it would be -1.
What would, the tangent?
Yeah.
Okay. Okay, so I can see how with the app, it's pretty clear how we would do this by, like with rulers and stuff. But it's not really clear how we would define it on a programming function.
Right. So I'll give you a little bit of history about the programming function.
Okay.
Essentially what we do is we cheat. We compute the values of sine, cosine, and tangent using calculus.
Okay.
Because it turns out that they're very, they're very useful. They're very easy to approximate using the methods of calculus.
Okay.
I'm afraid I'm going to have to defer your question until we come to calculus.
Okay. No problem.
Alright, great.
I think I've done enough for the recording of today to have I think it's pretty clear what, I think you did a really great job, Patrick.
Oh, thank you.
I wish I had used the microphone so that it wouldn't be echoey. Another day, would you mind going over it again with the recording it with the microphone?
Yeah, sure thing.
And it would also be good for me to review this, cause I think I really learned a lot.
Alright.
Well, I'm gonna stop the recording, okay?